Find the exact range of values of x for which e to the power of x log base 5, 3x minus 5 plus e to the power of x log base 5x is less than 0. Now for this, what I can do is I observe that both sides, both terms do have a common factor of e power x. So I'm just going to factorize out e power x log base 5, 3x minus 5 added to log base 5 of x to be less than 0. Okay, and from here, what do I do next is you recognize that e power x, right, is an exponential function, right? E power x is always more than 0, right? So I can just divide it away, and it's because it's not going to give me any solution. So I'm just going to rewrite log 5 3x minus 5 plus log 5x is less than 0. Okay, so I'm just going to divide by e power x, which is always more than 0, on both sides. Because e power x is not going to give me any solution, it's always going to be more than 0 on both sides. Now, using the product law of logarithms, where log a plus log b is the same as log ab, I now get that log base 5, 3x minus 5, this is the same as 3x squared minus 5x less than 0. Okay, because what I'm doing is I'm multiplying these two terms together. Right? Laws of logarithm tells me that if I have log ax plus log ay, this is just log a xy. Okay, because I'm using the product law of logarithms. So from here, 3x squared minus 5x less than 0. So what does it tell you if this term here is less than 0? Right? So simply we can convert this to the exponential form, right? From the logarithmic form, if I change this to the exponential form, this just gives me 3x minus 5x to be less than 5 to the power of 0, which in turn is just 1. Okay? Now remember that because the base here is more than 1, if I were to change it to the exponential form from the logarithmic form, it does not affect the direction. Only if the base is less than between 1 and 0 will the direction switch sign. So from here, my next inequality is 3x squared minus 5x less than 1, which is same as solving 3x squared minus 5x minus 1 less than 0. This gives me a very humble inequality. Now all I need to do is to go ahead and just solve for all the possible, okay, just by maybe using, I can use the quadratic formula, I can use the curve, right? So using the quadratic formula, I mean, if I just take x, considering this, if I just consider 3x squared minus 5x minus 1 equals to 0, then if I use the quadratic formula a, where I mean a is equals to 3, b equals to negative 5, and c equals to negative 1, x will be equals to negative b plus minus square root b squared minus 4ac over 2a, which will provide me with the answer, final answer, to be 5 plus minus square root 37 over 6. Why do I need this there? Okay, why? Because again, we need the roots, right, to help us to identify the curve, right? So if I have this curve here, which is y equals to 3x squared minus 5x minus 1, the two roots here, right, will be basically the solutions of 3x squared minus 5x minus 1 equals to 0. The one on the right will be 5 plus square root 37 over 2. The one on the left will be 5 minus square root 37 over 2. Right? Like I always tell you, when we solve a quadratic inequality, always sketch out the curve. And because we want less than 0, we are considering the y value, right, to be less than 0. Because y equals to this and is less than 0, which in turn will be the shaded in blue region. Okay, so from here, by observing, we know that x has to be between 5 plus square root 37 over 2 more than 5 minus square root 37 over 2. At the same time, do note that here x has to be positive and 3x minus 5 also has to be positive because they are part of the log function. Right? 3x minus 5 has to be more than 0. X has also to be more than 0. Alright? So here, x to be more than 5 over 3. Now, taking the intersection of all three answers, right, just put them out on a number line. Just draw out the number line. Okay, 0 is here. 5 over 3 probably somewhere here. Okay, so I have the first one in red, more than 0. Blue, more than 5 over 3. Okay, next in green, 5 minus square root 37 over 2. Let me just check what's the answer for this, right? So 5 plus square root 37, if you divide by 2, approximately this value is around 5.54138. And if you take 5 minus square root 37 divided by 2, this value is about negative 0.54138. Just so that we have a small sensing of where the value is supposed to be. Right? Right, so it's probably all the way to the right here, right, where this is 5 plus square root 37 over 2. Over here, this is 5 minus square root 37 over 2. Now, if I want the intersection of all three, you can see that definitely, just extending the red and the blue, the intersection will fall within this region here. This is the part where you have all yellow, green, red, blue lines to be intersected. Okay, so the set of solutions that satisfy all the inequalities will be 5 plus square root 37 over 2 on the right and 5 over 3 on the left. Thank you.